Yeah. So next part is like design part. So we'll see the design of flip flops using. I mean, a problem will be given, and based on that problem, we have to design the circuits. Okay. So that is what we have to do. So take this design procedure. So what we had to do earlier in analysis part, you'll be given the diagram. So in case of design part, you have to draw the diagram. So that will be the final step. Okay. So generally design means you'll be given the problem, and based on the problem, you have to draw the state diagram, and from the state diagram, you have to draw the state table, and from the state table, find the equations, simplified equations, input output equations, and after finding the equations, draw the logic diagram. So that is what we have to do here. So in most of the cases, okay. So this is how we have to do. So first of all, we have to give the description of the circuit behavior here. Okay. And we have to reduce the states if possible. I mean, we told you already, right? So if there is any possibility of state reduction, we have to do that state reduction. And next one is state assignment. So we'll do the state assignment to the this one given states here. So that is assigning the binary values. That is called a state assignment here. So next, obtain the binary coded state table. So state table in the sense, so what are the states we have? So it should be updated with the binary codes here instead of A, B, C, D like EF. So we'll write the binary codes. Okay, and choose the type of flip flops that has to be used here. Okay, and simplify the equations with the help of this state table and K maps there, and afterwards draw the logic diagram. So that is what we'll follow. So we'll straight away go to the problem here. So we'll be given the problems, and we'll see how to solve these kind of problems here. Okay. So wait a minute. So take down this problem. Wait. Yeah. 1 minute. So 1 minute. Yeah. Mm. So take down the problem. That is paint. So design a sequential circuit. Design a sequential circuit with two flip flops and two inputs x comma y. The excitation requirement for flip flops are as follows. Okay, so with I can say that with two D flip flops and అనుకోండి లేకుంటే flip flops అయినా పర్లేదు. You can see the equations now. So the input equations will be like this. So DA 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 is equal to, so this is the equations we'll get here. So A plus B into X. So X and Y are the inputs here. Okay, and DB is equal to A bar X and output Z is equal to A plus B X bar. So A plus B into X bar. Okay, so this is dB. Okay, so there is a problem given here. So we have to design the circuits here with two flip flops. So we have two flip flops and two inputs X and Y. Okay, so here even though they're given as X and Y, so we don't have any X Y inputs used here. Okay, so first of all, what we have to do here is, so we are given a problem here. So these are the flip flop input equations of D flip flop. So already we discussed about D flip flops. So D flip flops, whatever the input we give, that will be the next state. Okay, so what is Q of t plus 1 in case of D flip flop? So Q of t plus 1 is equal to Q of t plus 1 is equal to D. Okay, in case of D flip flop. Yes or no?
Yes, sir.
Yes,
Okay.
sir.
So whenever the inputs are given or whenever the next states are given, so they are assumed like, so the quite common fact is that, so if inputs are given or if the next states are given, so we can assume that input as a next state or next state as a inputs. Okay, so it is vice versa in both the cases here. Clear? Okay, it is vice versa in both the cases. So whenever we have a D flip flop, so when the inputs are given to the D flip flop, so obviously these inputs will be the next states also. These inputs will be the next state. So if I want A of t plus 1, so what is A of t plus 1? So it is dA. So what is dA? dA is equal to A plus B into X. So what is dB? It is A of B of t plus 1. So that is equal to A bar of X. So that is the case with D flip flop here. Or if you are given like A of t plus 1 is equal to A plus B into X, obviously the values of dA and dB are equal to A plus B into X and A bar into X, because D flip flop has that uh, thing here. So that is like, so what is the next stage? The next state will be the inputs here. Whenever the inputs are given, we can find the next states here. Okay, so here identifying number of flip flops here. So here we have two flip flops. Two flip flops are required. It is already told in the problem. Okay, so I'll name them as FFA, AIFF A, and FFB. FFB. Okay, so two flip flops. So the given two D flip flops here. Two D flip flops, because the inputs are given as like D flip flops, right? Okay, so FFA and FFB. Okay, and two inputs to two flip flops. So two inputs are given as DA and two inputs. Okay, so what are the two inputs here? So DA and DB. So these are the two inputs to the two flip flops. Okay, and outputs, what I can write it as A and B here. So outputs, outputs of these flip flops are nothing but, so I'll say that A of t plus 1 and B of t plus 1. Okay, so that will be the next stage. So present states and AB. The present states are nothing but, so AB, because here we are given like a DA, A plus B values are given here. So what I can say here is, so these are the outputs of the two flip flops. So A flip flop has the output of A here, B flip flop has output of B here. Okay, if I want next state, I'll name it as A of B plus 1, or I'll name it as B of t plus 1 here. Okay, so now what we can draw here, right? So here we have two inputs on our X and Y, and these are the equations here, and we have Z value of A plus B into X bar here. Okay, so Z value of A plus B into X bar. So what I have to draw here is, I'll draw a logic diagram first. Okay, so we have to design a sequential circuit here. So first of all, I'll design the sequential circuit because I have this flip-flop input equations. Okay, so when I have input equations, obviously when I have flip-flop input equations or output equations in case of the D flip-flop, so what I can do straight away is we can draw the diagram in case of the D flip-flop here. Okay, so we can draw the logic diagram of the circuit. Okay, so after drawing the logic diagram, so what I can do, I can draw the state table. From the state table, I can draw the state diagram. Okay, so you can check here. So this is the given problem. Okay, this is the given problem, and yeah, so two flip flops. So you can draw it side by side, or you can draw it up and down. So no problem. Okay, this is FFA, that is flip flop A, and this is FFB, flip flop B. Okay, and the inputs are DA. This is DA, and this is output here. We have A or A of t plus 1, and we have A bar, and this is B, and we have B bar. Okay, and we can use the clock here. So wherever we can find the clock, I can draw the clock here. So clock is drawn, and the clock is given to both the circuits. Okay, so draw in such a way that the two flip flops here. Okay, and this will be like A. This is A bar. This is B bar, and this will be the values will be like BA. So this is BA, and we have BB. Okay, now we have the values of DA is equal to A plus B into X bar. Okay, so DA is equal to A plus B into X here. So A plus B into X. So we have inputs like, so this is A here. Okay, and this is B. So we'll take the two values here. The two values are given to OR gate. Okay, so and we have inputs of X and Y, but we are using only X here. So this is OR gate. So the OR gate inputs will be from, so one is from A here, other is from B. So this is A plus B. Okay, so into X bar. So 1 minute. This is A plus B value. Okay, so this is we'll be having A plus B into X, right? So we'll be having X here, X input. This X input is given to an AND gate here, and this AND gate will carry the value of this one, and this is A plus B into X here. Clear? So this is the value of DA.
Yes,
Yes
sir.
or no? Okay. And next, what is the value we have? We have DB value is equal to A bar X. So where is A bar here? Say A bar. Okay. And where we have X here, so we have X. You can see this question like I can take X directly here. Okay, I'll put X here. Say A bar into X. So these both are given to AND gate. Okay. So that will be DB. So that is A bar into X here. and z, what we have z here, so that is equal to a plus b into x bar. So already we have a plus b here. Okay, and this is I'll give it to an inverter. So both multiplied here, so multiplied I'll get a value of z here. Clear?
Yes, sir.
Yes, sir.
So this is the logic diagram. So the first step here. Okay, so in case of D flip flop, it's quite easy. So I'm talking about D flip flops only right now. Okay, so in case of D flip flops, all these things are quite easy. So when you are given the next states, or when you are given the input values, so these things are quite easy. Okay, so when we talk about JK flip flops, so a little bit different strategy we have to follow with the case of JK flip flops, right? Yeah. Next, what we had to do here. So next we have to draw the state table here. Okay, so state tables we have to draw. So when we talk about state tables, so we have present states. Okay, and we should have inputs. Okay, so we have inputs here, and we have next states, and we have outputs. Okay, so present states, inputs, next states, and the output. So that is what we need in case of the state table. Okay, so when we are using two flip flops, we can get a maximum 2 power 2 square flip flop. So we have 2 power n here. So when 2 power n is considered, so we can get a 4 states. So maximum of 4 states here. So what I can assume, so first of all I'll assume this the values as S0, S1, S2, and S3. Okay, so generally in first case here, so what we have to, why we are using only when we are using two flip flops here, we'll be having two present states here. When we have two present states, the 4 states are possible. Okay, so 2 power n, so will be the number of states possible, number of possible states here, number of possible states. Okay, so where n is the number of flip flops, n number of flip flops. Okay, so maximum number of possible states is 4 here. Okay, so you can get a 4 state. So when I talk about state assignment, so state assignment before state assignment, we have to assume the number of states here. Okay, so number of states will be equal to, like I'll assume the states as S0, S1, S2, and S3. And the inputs we are using, even the problem is given like XY, so we'll take it as X only. Okay, so we have inputs of X only. Okay, and coming to the inputs here, so we have two possibilities of inputs here when X is equal to 0 and X is equal to 1. So generally when X is equal to 0, what is the next state? And when X is equal to 1, what will be the next state here? So that is the case we have to check here. So based on the things, based on the substitution, we'll get these values here. Okay, wait. So now what we have to do is we have the present states here, and we have next states, and we have output. So that is what we have to do here. Okay, so present states, inputs, and next states and outputs. So that is what we can check here. Okay, so we'll draw a diagram like this. Okay, so first of all, the table will be like this. The present states. Coming to the design, we'll start with the assignments only. Like so, we don't give any values like S0. So take note this table after the diagram. S0, S1, S2, and S3. Okay, and so what we need next states and outputs when input value X is equal to 0 and X is equal to 1. We have only one input here. So we'll make it as next state and Z. NS stands for next state and Z is output here. Okay, so next state and Z. So when X is equal to 0 and when X is equal to 1 here. Okay, X is equal to 0 and X is equal to 1. Okay, so this is what I had to check here. So what is the values of these states when x is equal to 0 and x is equal to 1? Okay, so how to check these values? So how to check the next states here? How to check the next states? So let's check this them.
If x is equal to
Uh,
0, it next state, sir.
if x, if x is equal to 0, so generally when we have four possible states, so what is the values we can get here? So generally s naught తీసుకున్నప్పుడు s naught s1 s2 s3 తీసుకున్నప్పుడు, so four possible states ఉంటాయి కాబట్టి what is the values I can assign here? So 0 0 0 1
0, 1, 1, 0, 1, 1.
1 0 1 0 1 1. Okay, so we will be having these values here. Okay, so 0 0 0 1 1 0 and 1 1. So under the values will be like these are the values of AB, right? These are the values of AB. Okay, so substitute these values. So substitute these values into the equations here. So what are the equations we get here? So dA is equal to A plus B into X, right? Okay, so what is the values of AB here? AB is equal to 0 0 and X is equal to 0, right? So all the values of AB and X are equal to 0 here. Okay, AB and X are equal to zeros. So when I substitute these values, what I'll get here? So what is the value of dA here?
0, sir.
0
0.
0. So 0 0 is nothing but the state S naught. 0 0 is nothing but the state S naught. Yes or no?
Yes, sir.
Okay, and what is the value of Z here? So when I substitute the values of A is 0, B is 0, and this X is equal to 0. But we will get X is equal to 0 to X bar 1 aitundi, but Z is also equal to 0 here. Okay, so Z is also equal to 0. Okay, and now substitute the values of X is equal to 1. AB is 0 0, but X is equal to 1. So AB 0 0, X is equal to 1 aithe. So what is the value of when X is equal to 1? So what is the value of this here? So what it will do? So what is the next state? So the values of ABR is equal to 0 0 here. Okay, so when I substitute the values of AB is equal to 0 0, so what is the value of when X is equal to 1?
1, sir.
S1 0, sir.
S1 first statement.
0. S1 and
0.
0. Yeah, so S1 and 0. Okay, and how about the next one here? So S1 0 1 ఉన్నప్పుడు, so when X is equal to 0, so AB values are equal to, so AB is equal to 0 1 here. Okay, so AB is equal to 0 1. So what is the output I'll get here? So what is the output I'll get? So A value, DA value will be equal to, so AB is 0 1. So this is 0 and this is 1. And what is the value of X here? X is equal to 0. Okay, so X is 0 కాబట్టి, so I'll get a value of dA as 0. And what is the value of dB here? A bar X here. So A value is 0, so I'll get a 1 here, and X value is 0, so a 1 into 0 will be 0. Okay, so again AB values are equal to dA and dB values are equal to 0 0, hence I'll get a S0. And what is the value of Z here? So Z is equal to A plus B into X bar. So A is 0, B is 1 here. So B is 1 కాబట్టి you will get a 1 here. So 0 bar. So X is 0 here. So 0 bar is 1. 1 into 1, I'll get a 1. Clear?
Yes, sir.
Okay. Next, 0 1 is substituted, and when X is equal to 1. When X is equal to 1, I'll substitute the values of 0 1. So dA is equal to, so A plus B into X here. So values of A plus B is 0 plus 1. X is value is 1 here. X value is 1. So 0 plus 1 is 1, and 1 into 1 is 1. dA value. Okay. And dB value A bar into X. So A value is 0. A bar value is 1. So X value is 1. So dB is equal to 1 here. So A and B values are equal to 1 1 here. So 1 1 in the sense I'll get a value of S3. I'll get a value of S3. And coming to a plus b into x bar, a plus b into x is 1, x bar is 0. So 0 into anything is 0 here. Okay. Next coming to 1, 0. If I substitute the values of 1, 0, so 1 plus 0 into 0. So x bar x is 0 here. And next coming to db here. So here we have a as 1 year. So if I substitute the value of a as 1 year, I'll get a 0 here. Again, it's at 0, 0. And coming to z here. So a is 1 year. So b is 0, 1 plus 0 into x bar is x is 0 here. X bar is 1. Okay. Hence, I'll get a S naught 0, 0 and S1, and here I'll get a, so what is the value I'll get here? So a plus b is 1, 0. Okay, so dA value is a plus b is 1, 0. So 1 plus 0 is 1 and x value is 1 year. So I'll get a value of 1 year. Okay, so dA value is 1 and dB value, okay, is a bar x here. So what is the value of a here? So a is 1 year. Sorry, yeah, a is 1 and the b value is, what is that I'll get here? So b value is 0. I mean x value is 1 year. X value is 1. Okay, and b value is 0 here. So what is that I'll get here? So I'll get a value of 1, 0. So 1, 0 is nothing but
S2
S2.
0.
Okay, S2 and 0.
0.
Coming to S3. S3 both are 1, 1. So 1 plus 1 into 0. So it's a 0. Okay. So, and here, so 1 is, we have 1 here. So a bar is 0. So here it's also equal to 0. Okay. Hence I'll get a S naught. And the output is a plus b. A plus b is 1. 1. X bar is 1 here. So I'll get a 1. Okay. In a similar way, so if x is equal to 1. So a plus b is 1 and x is 1. So it is equal to 1 year. And a bar x. So a is 1 year, a bar is 0. So I'll get a 1, 0. So 1, 0 is nothing but S2 comma 0. Okay. So this is the truth table here. Okay. So before, and the values are assigned like this. S naught, S1, S naught is equal to 0, 0. S1 is equal to, so 0, 1. S2 is equal to, so 1, 0. S3 is equal to 1, 1. Okay. So Ilanaji Indi, it's fine, or else you go for the elaborated truth table. Okay. So state table, what we can do here is, so we can draw a simple state table here. Okay. So the simple state table will be like this. 1 minute. Okay. So you can take this. Okay. So this is state table, and you can assign these values, and you can draw the state diagram also. So from this you can draw the state diagram also. But we have another way also. So I'll let you know the another way. So normal method we'll follow. So that is the most of the times we'll follow that method. Okay. So the methods will be like present state, input, so next state, output. Okay. So present state we have two flip-flops got A, B, and input is X here, and next state is A of t plus 1 and B of t plus 1. This is a method we'll generally follow. So we'll just go with this method only. So B of t plus 1. Okay, and output is Z. Okay. So we have A of t plus 1. So what is that in case of D flip-flop? What is the value? What is meaning of A of t plus 1? So what is A of t plus 1 generally? So what is A of t plus 1 in case of D flip-flop?
D, sir.
A of t plus 1 is equal to D.
D.
Okay. So that is nothing but, so DA. So A of t plus 1 is equal to DA, and B of t plus 1 is equal to, B of t plus 1 is equal to
DB, sir.
DB. Okay. So remember, because this is a D flip-flop, so you remember that. So this is equal to DA and this is equal to DB. Clear?
Yeah, sir.
Okay.
Yeah,
So
sir.
now we have present states of 2, right? So we have 4 possible states like 0, 0. Okay. And x is equal to 0 and x is equal to 1. So we have present states and inputs. Totally we'll get 8 states here. 0, 0, 0, 0, 0, 1. So this is and 0, 0, 0, 1, 0, 0, 1, 1. So these are next 2 states here. And next is 1, 0, 0. So 1, 0, 1. Okay. And substitute these values. So what are those values here? So what is the value of a of t plus 1? So a of t plus 1 is equal to dA is equal to a plus b into x. A plus b into. So with d flip-flops we can do this. With d flip-flops we can do this. So a plus b into x. So what is b of t plus 1? So what is b of t plus 1? It is equal to db and db value is equal to a bar x. So db value is equal to a bar into x here. Yes or no?
Yes, sir.
So z is
Yeah,
equal
sir.
to a plus b into x bar. Okay. So what we can do here is, okay. So we can substitute all these values. So it is like 1, 1. So 1, 1, 0 and triple 1. So first of all, write all these combinations and substitute the values. So the values I am just writing the values. Just substitute those values in a of t plus 1 and b of t plus 1 equations, and what equations are nothing but dA and dB. So we'll get these values. So 0, 0, 0, 1, and next we have 0, 0, 1, 1. Next we have 0, 0, 1, 0. Next we have 0, 0, 1, 0. And outputs are 0, 0, 1, 0, 1, 0, and 1, 0. So this is the state table we'll get here. Okay. So normal, you follow this method: the present states, inputs, next states, and the outputs. You follow this method. Okay. And in case of D flip-flops, if you are given DA and DB values, so remember that. So those are equal to, so A of t plus 1 and B of t plus 1. Okay. Or if you are given like A of t plus 1, okay. So remember that A of t plus 1 is equal to dA, or dA is equal to A of t plus 1. I mean, what are the inputs and outputs equations, next state equations, those can be interchanged. Those values can be interchanged in case of the D flip-flop. So getting my point here.
Yes, sir.
Okay. So this is the table we'll get here. Now we have to draw the state diagram. Okay. So how to draw the state diagram? So you can use this table, or else you can use this also. We have 4 possible states here: 0, 0, 0, 1. So 1, 0, 1, 1. So these are the 4 possible states. Okay. And we have 4 possible transitions here. Okay. So x is equal to 0. So 0, 0 aithe, it will remain in the same state when x is equal to 0. Okay. And what is output here? Output is equal to 0. Okay. And if it is like 0, 0, if input is equal to 1, it will go to the next state 0, 1. Okay. Input is equal to 1, and the output is also equal to 0 here. And coming to this one, 0, 1, and input is equal to 0. So 0, 1 is the state, input is equal to 0, it will go to the state 0, 0. Okay. So 0, 0, input is equal to 0, it will go to the state 0, 1, I mean 0, 0, and output is equal to 1. Okay. And 0, 1, if input is equal to 1, it will go state 1, 1. and output is equal to 0. And if it is like 1 0, and if it is 1 0, input is 0, it will go to state 0 0, output is equal to 1. 1 0, if the input is equal to 1, it will go to the state 1 0, so it remains in the same state. If the input is 1 and output is equal to 0. And coming to 1 1, if the input is 0, it will go to the state 0 0, output is equal to 1 here. If it is 1 1, if the input is 1, it will go state 1 0. Okay, output is 0 here. So this is the state diagram. Clear?
Yes, sir.
No, sir.
Okay, so if you are confused, so don't go with this. So just so have the present states. So 2 flip flops, 2 present states. Okay. So if it is like flip flop names ichinte, like if you are given like PQ, so PQ are the present states. The next states will be P of T plus 1 and Q of T plus 1. So here the 2 flip flops A and B and assume చేసుకున్నాం కాబట్టి so A and B 2 flip flops. Okay, and the next states will be A of T plus 1 and B of T plus 1. And if the inputs are given like DA and DB, so obviously when D flip flop is used, so next states will be A of T plus 1 and B of T plus 1 is equal to DA and DB. So that is the thing in case of the D flip flop. We have that advantage in case of the D flip flop. Okay, so find the present states inputs and substitute these values. So ABX values into the input equations and output equations and get these values and identify the number of possible states here. 2 flip flops here, so 4 possible states are seen here. So write all the 4 possible states and when inputs x is equal to 0 and x is equal to 1, so write the all possible transitions here. So what is the next state when input is given as x is equal to 0 and x is equal to 1 from the present state here? Clear?
Yes, sir.
Okay,
Yes, sir.
how the problems will be like kind of exercise problems. Okay, so iste ivochu lekunte ledu, and I'm not sure whether your problems will be given అని చెప్పను lekunte problems ఇస్తారు లేదు చెప్పను, but these kinds are exercise problems. These are the kinds of exercise problems. So when you are doing solving more problems, you will understand the functionality of the circuits. Clear? So clear with this problem? Have you taken this problem and diagram? You can take this 2 tables, so you can take this one and afterwards you can follow this one also. Okay, and this diagram.
Yes, sir.
Okay, sir.
Okay, yeah, so next we'll see the next problem. So take note this problem. సో హర్లియర్ ఎగ్జాంపుల్ ఏంటంటే డిఏ వాల్యూస్ డిబి వాల్యూస్ ఇచ్చారు. ఇక్కడ ఏంటంటే వీఆర్ గివెన్ ద వాల్యూస్ ఆఫ్ ఏ ఆఫ్ టీ ప్లస్ 1 and B of T plus 1. Okay, you can see the difference here. So we are talking about D flip flops only. So taking this problem. Clear?
Yes, sir.
Okay. So in this problem, so what you can see here is given the values of a of t plus 1 and b of t plus 1, and z is given as b here. So we have to draw the logic diagram of the circuit. So list the state table and draw the corresponding state diagram. Okay. So here we are given the values of a of t plus 1. So now I can conclude, like when you are using d flip flops here. Okay. So a of t plus 1 is equal to this values, and then d of a is also equal to x bar y plus xa. Yes or no?
Yes, sir.
And dB value is equal to x bar b plus xa. Okay. So now what I have to do? I have to draw the logic diagram here. Okay. So after logic diagram, draw the state table here, and we'll draw the state diagram. Okay.
Sir.
Yeah. So first of all, draw the logic diagram. Right. So logic diagram. So what is the problem here? So wait a minute. So there is a problem. So a of t plus 1 is equal to x bar y. Okay. So hence that is equal to dA, and we have dB also. We will be having two flip flops here. Okay. So two flip flops. So flip flop A and flip flop B. This dA. This is dB. This is A bar, B, B bar, and we have a clock here. So the clocks are given like this. So two clocks. Two clocks. This is clock. This is also another clock here. And what is the value of dA? X bar, y, and xa. So we have two values, x and y. So x and y values. So what is the value of this one, x bar y plus xa? So we'll be having a OR gate in front of the output. So addition of x bar y. So one is x bar y, another one is xa. That other one is xa here. So we will be having two AND gates here. Okay, and the AND gate outputs are like this. Okay, the AND gate outputs are like this. We'll be having x bar, right? So this is x here. So this is x a. So where is the value of a? So we'll get the value from a here. This is xa. Okay, and other one is x bar y. So this is xa here plus x bar y. So this is x here. So we'll get x bar. Okay, and next we'll get a value of y. Okay, this is x bar y here. So that is the value of dA. Clear?
Yes, sir.
Okay, next x bar b plus xa. So we'll have x bar b plus xa. Okay, so xa. So we'll again have an OR gate. So this is, and this is also we'll be having two AND gates. The two AND gates are given to an OR gate here. So one should be xa, another one should be x bar b. So we'll be having x bar b. So this I can take it as x bar here, right? This is x bar, and I have b value. So from here, x bar b, okay, plus xa here. So this is x, and this is xa. Okay. So కొంచెం నీట్ డ్రా చేయండి. Okay, so a little bit of need to draw చేయండి, and we have z here, so z is equal to b. So it was told like z is equal to b, and ఇక్కడ b ఉంది కాబట్టి this will be equal to z. Okay, so there is a logic diagram.
Yes, sir.
Okay, so next what we have to do, we have to draw the state table. Okay, so we have to draw the state table here. So state table, so what we need here, so what are the inputs here? One minute. So inputs, so inputs are x comma y are the inputs, and present states we have two flip-flops got and giving it as a and b. Okay, so total we got 16 combinations here. Okay, and we have two flip-flops, 4 possible states. Clear?
Yeah, sir.
Yes, sir.
Okay. Yeah, so present states, you follow this method, so most of the times you follow this method. So present states, inputs, the next states, ns, outputs. Okay, so present states are nothing but a and b. So inputs are x and y. So we have 4 inputs here, I mean 2 inputs and 2 present states, so 16 combinations we'll get here. And next a of t plus 1, and next we have b of t plus 1. Output is z, so that is equal to b. Okay, so write the values from 0 0 0 to 1 1 1 1, so 16 values. So write all those values. Okay, this is how it will be. Okay, substitute చేయండి, ఈ వాల్యూ సబ్స్టిట్యూట్ చేసుకుంటే we'll get those values. Try to spoil this. Yeah, this is how it will be. So present state values from AB 00002. So we'll be having 1111. I substitute these values in D of A, that is A of t plus 1, so which is also equal to A of t plus 1. So we have the equations of A of t plus 1. Okay, and we have B of t plus 1. Okay, and if I substitute these values in these equations, I'll get these values, and Z is nothing but B. What are values of B here? So those values are copied to Z also. Okay.
Yes, sir.
Any doubts in this?
No, sir.
Okay. And next, we have to draw the state diagram here. So we check the values of AB. We'll be having four possible states here: 0000, 0001. So 111010. So and 1111. So we have four possible states here. Okay. And we have to draw the state diagram here. Okay. So coming to this one. So if I say that S naught is equal to, so this is S naught, the value is S naught here, and xy, we have inputs of two inputs here. Xy is equal to 00 is there, it will remain in the same state. Okay, so if I say it like this, S naught, S1, S2, and S3. Okay, so S naught here, you can check here 00. If the input is 00, it will remain in the 00 state only. If input is 00, it will remain in the same state only. And what is output here? Output is 0. Clear? So please respond.
Yes, sir.
Yes, sir.
And here 00, and the input is 01, it will go to state 10. Okay, so what is 10? S naught is 00, it is 01, S2 is 10. If the input is 01, okay, it will go to state S2 here, and output is equal to 0. Okay, and if we state S0, it's like 00, input is 10. Okay, it will go state 00. So for 10 also, it will remain in the same state, and output is 0. Comma, I'll put it as a comma here. Okay, and 00, if output is like input is equal to 11, it will remain in the same state, output is equal to 0. So for 11 also, the output is 0, it will remain in the same state. So this S naught part is completed. Next, coming to, we'll go for S1. So 01. So 01, if the inputs are is equal to 00, it will go to state 01 only. I mean, it will remain in the same state. Okay, and the output is 1. Okay, so in a similar way, you can do all these things. So when we have this table, you can draw all these things here.
Okay, sir.
Okay, yeah, so I don't want to waste time here. So this is with the help of D flip-flops. So this is with the help of D flip-flops, and it is how it will be. Okay, so ఇదే స్టైల్లో రావాలని లేదు, just follow any kind of method. So you can S0, S1, S2, S3 పెట్టడం కంటే you can have the binary values also 0001 అని పెట్టచ్చు. But this thing should be correct. The table should be correct here. Clear?
Yeah, sir.
Yeah, so this is with the D flip-flops. The next class we'll see with the JK flip-flops. Okay, so tomorrow morning or afternoon I'll be taking the class. So this is the D flip-flops kind of thing. So solve more and more problems. Okay, so next class we'll see the JK flip-flops and we'll see the T flip-flops. So that design part will be completed with that. Okay, so once you come to the college, I don't know, you don't ask me when the college will be. So I was told like another 10 days, maybe, I don't know. So when you come here, so you'll be having some lab sessions. So I'll take the classes for every day, like 1 hour, 1.5 hours. I'll be taking this class also, Okay, so what we'll do, we'll solve extra problems, and if you have any doubts, please let me know, and listen to those recordings repeatedly. Okay, so we'll take the class sessions also,
Okay, sir.
right? Yeah, so meanwhile you complete this problem. So మీరు కంప్లీట్ చేయండి, ప్రాబ్లం కంప్లీట్ చేసి స్టేట్ డయాగ్రామ్ వేయండి ఈ ప్రాబ్లం గురించి, రైట్?
Yes, sir.
Yeah, so drop your attendance and see you tomorrow.
Thank you, sir.
Thank you, and have a nice day.